And we are live now. So, hey folks, this is me, Vishwas Nayan. I'm the host of this webinar. Lot of lot of things that are happening with respect to anything, anything and everything that we are talking Kubernetes, everything and everything that we are talking about cloud, this and that. But there's always a strategy that always comes and plays in the picture. And in a meanwhile, even if you figure out what's happening, it's just the strategies that are working. And I'm with Turja Chaudhuri, who's going to give you a lot of insights about how enterprises deal with architecture every single day. And over to you, sir. Let's start with first question, and then we can go on with the session as well. So over to you.
No, perfect. So see, the first question in a sense is how do enterprises deal with architecture, right?
Yes.
And the idea here is that will be now in focus of the session. So at a high level, many people will think architecture is all about doing great solution architecture diagrams, great infrastructure architecture diagrams. For example, going with a lot of complexities, trying to solve, all of which is true. But for example, in the words of the famous architect, enterprise architect and strategist Gregor Hoff, who is currently in AWS, architects sell options. So as an architect, your main idea is to be a socio-functional or socio-technical collaborator or a facilitator. Basically, facilitate conversations, guide people on the correct path. So most of your day, maybe 60 to 70% of day will be to achieve consensus. Somebody is wanting to say, for example, deploy something on Azure. Somebody wants to deploy on AWS. And what we want to do effectively is kind of give the right path to move forward.
Sure, I got it. So I think that's the best part about it. So I just want to ask you one question. So how do you deal with cloud complexities, and what is it all about when you think how not to complicate the architecture or anything like that? So that's the question, sir.
No, that's a very valid question. But now coming to your question, how to deal with complexity in everyday life, including IT architectures. So going back to the foundations, going back to the basics always helps. Okay, that is one of the fundamental things that we need to do. And at the same time, some of the other things that kind of helps in a sense is, for example, uh, having something like the thing is that in complexity, basically you have to kind of get to the bottom of what is the actual problem that you want to solve. So say for example, at a high level in architecture diagrams, you might be doing a lot of asynchronous. For example, you might be running an Azure batch, you might be setting up a Kubernetes cluster, but that could have been simply done by maybe a very simple SQL Server stored procedure. Right. So those kind of things, there is no sense in complicating the solution. Many times because of the newness of stuff, for example, okay, let's implement blockchain, let's implement AWS Lambda, let's implement Google Kubernetes engine. Everybody's on Kubernetes. Why am I just running a simple application? For example, I read a blog a few months back that with all of this push from monolith to microservices, that, okay, I have to split up my service into small things. But at the same time, Stack Overflow is still running as a monolith. Who could have thought, right? They are handling so much, hundreds and millions of users, maybe concurrent users are using Stack Overflow, but they're still running as a monolith. They have written a blog about it. So anyways, this is kind of what my one advice would be. This is something I've learned the hard way, is to not overcomplicate stuff. Try to be as simple as possible and try to really understand that whether the new technology is adding value, because it's all about a kind of a return on investment. The more microservices, for example, you're moving, obviously you are getting independence, you're getting scalability, but at the same time, you have a lot of jitter. You say, for example, if service fails, then how does the downstream applications take care of that failure, circuit breakers, many kind of patterns. So it's very important to understand that these things are not very simple. So this is my one suggestion, maybe, for example, to the audience here.
Sure. I think before starting the session, I think probably it's better we can just start with the slide share and we can go on with the session so that we can just go ahead with all the practices that you wanted to share to us.
Okay, then let's start. How do enterprises deal with architecture? Okay, again, thank you all for being here, and a big thank you to the Devtron team, and again, Vishwas Naran for connecting with me and agreeing to host this event and for inviting me over. Really appreciate this chance and to get to such a great audience. And you guys are doing a really wonderful work. Kudos to you. You are doing a lot for the community. Thank you. Okay, brief about me. Currently, I'm working as an assistant director, basically in the cloud practice of EY, Ernst& Young, GDS, Global Delivery Services. I mainly am part of the platform engineering team. Before that, I used to lead the Cloud Center of Excellence team at Accenture. For around 3 years, I did that. I have around overall 11 years of experience in IT, and I've been working on public cloud technologies since 2017. I initially started with say, Amazon Web Services, and then I have kind of moved on to Azure. So what is the agenda? So the section one is the first is the introduction to architecture. So what is architecture and why do we need architecture and who are we as architects? So that is the most important thing I would like to kind of focus on for a majority of my session here. Section 2 is agile architecture. How does architecture fit in with our agile? How does architecture fit in with the idea of Scrum? For example, because the requirements will be changing, then do my architecture also need to change with every single sprint? Those kind of questions. Section 3 will be with kind of a focus on enterprise architecture. How do architecture teams have to kind of structure themselves so that they can add the most value to an enterprise? And section 4 is the conclusion. Okay, let's start with introduction to architecture, the what and the why. So what is architecture? As you can see from this meme, you can't have a bad app architecture if you don't have any architecture. But that's not the way we want to go with things, right? We want architecture, whether it's IT architecture, enterprise architecture, security architecture, cloud architecture, whatever you say, we want a way to manage our system, and that is why we need an architecture for our system. What is the definition of an architecture? This is the formal definition as per IEEE. Again, this definition is so convoluted and so complex that it makes no sense. But if you go to Google and search about architecture definition, this is the first definition that will come to you. But as I said, I don't understand this definition. So let's make architecture simpler. Let's try to find a definition that works. So this is a very well-renowned architect, Grady Booch. I'm a huge fan of him. He's an IBM fellow. So he said, architecture represents the set of significant design decisions that shape the structure and the behavior of a system where significance is measured by cost of change. Again, a little bit more complicated, but again, much better than the IEEE question. So what it is saying, it's saying architecture is a set of significant decisions. If you get that decision wrong, you have to pay a lot of price. The price could be effort, the price could be money to remediate that decision. So try to understand this. This is very important. So let's again distill it a little bit further. Architecture is a set of design decisions that must be made early. So this is a very simple kind of a definition, again by another architecture guru. He works in ThoughtWorks for a long time, Martin Fowler. Many of you might have read his books or articles. So any design decision that needs to be made early in the program is an architectural decision. Now, why does it need to be made early? If you go here, it's saying, Matthew Parker, again, one of my favorite persons, he says, in the field of software development, architecture are set of decisions which are hard to reverse. So now you can kind of put it all together. Martin Fowler is saying it's a set of decisions that needs to be taken earlier. Matthew Parker is saying it's a set of decisions that are hard to reverse. If we combine, we have to take these decisions earlier and get it right as much as possible based on the inputs at that time, because if we fail to do that and we reach the end of the project or the journey and we find that no, our decision was a wrong decision, they are very hard to reverse. So let's take an example. Say, for example, let's take a very simple example. What programming language should you use for your application development? You might think that no, it's not an architectural decision, it's an engineering decision, but no. Let's think of it. You are starting a project. Your engineering lead takes a decision that he will work on C#. The entire project starts. Everybody is working on C#. Over 6 months, you understand that many of the stuff that you are doing in C# would have been much easier, much easier, much more performant, much more memory intensive or efficient if you would have used the language Go. But now, after 6 months, is it really so easy to reverse the decision and just go from C sharp to Go? Is there any programming program or anything in the world that can just you can just click a button and change your C sharp code to Go? No, there is nothing today, right? So that is it. Even the decision as simple as what programming language should you use for your application development is an architectural decision, because it is a decision that if you get it wrong, it's very hard to reverse, and that is why it has to be taken correctly in the early phase. And that is why architects, whether they're IT architects, enterprise architects, cloud architects, get so much money. The reason is that they are the custodians of those decisions. They need that breadth and the depth of the entire ecosystem to be able to take those decisions early. Because if they get those decisions wrong, then the entire project will have to pay a huge price for it. Similarly, say for example, another example if we take is based on synchronous and asynchronous communication. So say for example, you're as an architect, you are saying that no, all of my communication for a particular unit of programming should be asynchronous or API based. Sorry, synchronous or API based. What does it mean? Means I will send a message, maybe an API call, and I'll wait for the answer to come back. The HTTP code, say 200 to come back. It's a synchronous. I will not just send the API and go on with my work, which is more like an event-driven or event bus-based asynchronous messaging kind of a system, like which uses SysQS or RabbitMQ. So what I'm saying, so the decision to implement a synchronous communication methodology or an asynchronous communication methodology is an architectural decision. As an engineer, as a developer, you don't decide. An architect will most likely work with your team and decide that yes, asynchronous is the best for this kind of a scenario. Now say he gets it wrong. Is it really so simple to change from an event bus or a queue-based, asynchronous-based system of communication to a synchronous kind of an API-based communication? No, it's not at all simple. And that is why architects have a very hard job, because they have to get those very crucial decisions, which we call architectural decisions, right. And most of those decisions, many of those decisions have to be taken at the beginning of the project, and they have to be taken correctly. And that is why you need a wide range of knowledge and a good depth of some specific items to be a good architect. So now we have defined architecture. Architecture is a set of design decisions that you need to take early, because if you get it wrong, they are very hard to reverse, right? So you need to get them early and you need to get them correct early. But then who are architects? Let's see this example. Okay, so if you see, it's basically a cylinder. But to the person who is on the left, she's saying this is a circle. And the person who is on the right, he's saying this is a rectangle. But we know that it's not a matter of it being a circle or a rectangle, it's a cylinder. So what is happening here? What's happening here is that both of them have different perspectives, but none of them have the total picture. The reality is often more complex. If you see something, a problem at just one angle, you will find a solution just for your point of view, your vision. But an architect is supposed to have an holistic view of the decision, of the entire system. An architect should have that maturity, should have that competence to understand that no, this is not a circle, this is not a rectangle. Maybe you see it as a circle from that perspective, from that architectural view. This guy sees it as a rectangle from this architectural point of view, but the actual thing is a cylinder. So we should treat it as a cylinder. So that is the additional value that an architect is giving. That is what makes it so interesting. So architects have a holistic understanding of the entire system across a different spectrum of views and viewpoints, and they offer a very, very different perspective of the system. So as a developer, as an engineer, you might be thinking a system as a 1D kind of one-dimensional 1D kind of a model, but actually it might be a 3D model. So that is where the architect will help you understand the nuances, the different views and the different viewpoints with which you can approach your ecosystem or your program or your problem. And this is again Gregor Hoff, who I was quoting a few minutes back. An architect doesn't have to be the smartest person in the room. Instead, through coaching, through kind of helping people be better than what they are today, they will make everybody else smarter. So that is why I was telling, which was that an architect's main job is to foster collaboration. You cannot do everything on your own. The main purpose of an architect is to kind of help people be better than what they are today by showing them the view. So in this case, for example, if this is a developer, this is another developer, as an architect, I am supposed to coach them, collaborate with them so that I can help them see the bigger vision. I can help them see that no, this is not a circle, this is not a rectangle, this is actually a cylinder. Perfect. Now, this is an anatomy of a high level architect. So from the outside, you might see, okay, this guy is an architect, but what is underneath? Maybe he was initially in IT support. Then he did some system engineering. Maybe he went on to some DevOps. Maybe he has done some a little bit data engineering kind of a role. Maybe he played a developer. You never know. So just because you are seeing that somebody is an architect doesn't mean that he has just become an architect from day one. Most likely he has done many of this kind of other roles, supporting roles, maybe development, maybe operations, maybe database admin, maybe system engineering, DevOps, security architect, or security engineer. All of those roles maybe they have done before, and as a result of that experience, now he has that high level vision, that overall holistic vision of how an enterprise system should work like. But this is good. We know what is architecture, we know who are architects, but why do we need architecture? This is again another very nice quote that I really like. It says, if you think good architecture is expensive, try bad architecture. Okay, this is again very nice kind of a quote. So architecture matters. Why? Why does architecture matter? If all of us are saying, okay, let's hire architects because architecture matters, we want to get our architecture right the first time. But why? The thing is that bad architecture or no architecture or less architecture will slow down the ability of your customer, who is the main consumer of your product, to compete, as over time it will become harder and harder to ship new features. So many times I have seen people say, no, I need architecture because it's the best thing, it's the correct thing to do. No, you have to define your architecture or defend your architecture practice from a business, from a revenue angle. The angle is very simple. If the business does not invest in an architectural team today, they will not have the capability, they will not have that maintainability, extensibility of their product, because of which over time, over a few years, it will become harder and harder to maintain that product, to add new features to that product. This graph, okay, which is called a design stamina hypothesis, again drawn by Martin Fowler, and all of the references to all of this content is in another slide, so you will have access to all of this. So if you see what is happening here, there are two lines. One is the red line, which I'm calling good architecture or good design. Another is the blue line, which is the no design or no architecture. If you see, the no design architecture starts a little bit better. Why? Because the moment they get the problem, they are starting working on it. They are starting the coding. They are not thinking about architecture. That is why initially they are able to do more user stories than me or you. But the team which has the good design, who has invested in architecture upfront, who took those difficult architectural decisions that needs to be taken early because they are very hard to reverse later, they are initially behind. But over time, you can see it becomes much easier for them to add new features because they have a good, strong foundation. They have a good architectural base. That is why over time they are able to add more features. Their solution is more scalable, more secure, more extensible, and more manageable. So that is why I'm saying good architecture matters, not because it's the correct thing to do or something noble thing to do. Good architecture matters because it gives your customers, gives your business the competitive advantage it needs in this market. Without good design, they will not be able to compete in this market, and over time the product will die because it will be too hard to maintain the product. Okay, perfect. So this was the section on what is architecture and who are architects and why do we need architecture. So I will just take a brief pause here in case Vishwas, there is anything that you would like me to focus on, or anything, any questions or anything. Otherwise, I will move on to the next section. Perfect. So I'm taking it as a no, and I'm moving on to the next slide. 1 second. Perfect. I
Yes,
hope I'm
sir. There
audible.
were some.
Okay, there were some
There were
questions, right?
some questions. Yeah, yeah.
Okay.
Basically, the role requires collaboration when we talk STLC. We often see a lack of documentation around it when it comes to legacy architecture. How to address this problem statement? We're here to deal with brownfield architecture.
Yes, true. See, again, that is what an architecture practice and how you shape your architecture and what are some of the architectural artifacts that are very important. So it can be a solution architecture diagram. It can be architecture decision records, which I have gone over my, but I get the question very, it's a very valid question in a sense that, say, for example, somebody created an architecture. Okay, and now that guy has left the company. They have left, for example, EY. Then what do? I am the new architect in that program. If I don't have the documentation, if I don't know why that guy took the decision, say for example, I come to the program and I see he chose a NoSQL database like Cosmos DB over a SQL or a relational data store. But if I don't know why that choice was taken, if I have to again understand it from scratch, then what was the point, right? So it's not only what was chosen, it was also why it was chosen. What are the design decisions or the steps that led to this architecture? Okay, so that is also very important, which we call architecture design records. And along with that, there are a lot of architectural artifacts which are solution architect or an IT architect or an enterprise architect is supposed to create. I can go over a few of them, but I get the point. When I go to the architecture design records kind of the section, I will focus on that. Does that make sense?
Sure, sir. Yeah, yeah. I think this makes a lot of sense. I think it's time to move for the second slide.
Perfect. So the section 2 is an agile architecture. So see, normally when we think about architecture, initially, for example, even when my career started, we used to do architecture at the beginning of the program. Okay, we will need one database, we will need a web server, we will need an app server, we will need an SSIS integration runtime to do the data load. All of that is done, the architecture is done based on the business requirements, and then we started to code. This is a traditional kind of a model. But in today's world, this model does not make any sense, right? We know waterfall does not work for most of the projects today. So what is the new model? The new model is agile. So in agile model, what is the difference? That your requirements are coming every sprint in a sense, right? So you have a chance to change your direction of the product based on the feedback from customers. These are all the benefits of agile. But then how does architecture fit in an agile kind of a workflow? That is what we call agile architecture. If we don't have agile architecture, what will we have? We will have something that is called ivory tower architects. What does ivory tower architect means? It means the normal way we think of an architect as if he's sitting on an ivory tower. The development team is much below. They have no idea why the architect is taking a decision. The architect has taken a decision maybe in the month of April. The development team is facing a problem in the month of June. The architect is not helping them out, right? So based on the new requirements that are coming from the customers, the architect is refusing to change their architecture. There is a lack of transparency, there is a lack of understanding. So this is what is waterfall kind of an architecture, where you do the architecture at the beginning of your kind of an exercise, and then you kind of don't follow up, don't work, don't collaborate with your development team, don't explain your decisions. You just have taken a decision, kind of sitting in an ivory tower saying, no, we need to use NoSQL database. Why? What are the advantages of SQL, relational data store? What are the disadvantages? What is the architectural trade off? You need to write all of this down and explain to your development team, your product teams. Otherwise, you are just an ivory tower architect. This is what, for example, many of us have encountered in our life, ivory tower architects who put on that kind of, they're put on a pedestal and they're doing whatever they want. They're not communicating. But this is not how enterprises can function anymore. Today, if you see ivory tower architects, that project is kind of bound to do. So then what is it we do? So we want to be agile, but at the same time, we want an architecture. I cannot wait that no, I will not have any architecture diagram because I do not have the complete set of requirements. Because in agile, I will never have the complete set of requirements on day one. My requirements will continue to be refined, so my architecture also continues to be refined. But does that mean today I am doing, for example, a SQL Server relational database kind of an architecture? After 3 months, because of a requirement that has come in from the business, I change it to NoSQL. Can my architecture just not follow any algorithm, any logic, and just change like whatever it wants? No, that also we cannot allow, right? So there's a concept of my immediate architecture and my architectural intent. So my architectural intent is what I have to first create. That is kind of my vision. So my architectural intent could be I want to create a loosely coupled microservice based application that relies on event driven architecture or event driven notifications. Something along those lines could be my intent. My immediate architecture might be a monolith. It could be. To get started quickly, maybe I am on the monolith, but my architecture intent is there. And during this journey, over the sprints, over the agile sprints, I am changing my architecture gradually, but true to the architectural intent. Over time, my immediate architecture will change, obviously, but my architectural intent will also change, but not that much. So the architectural intent is the intent, the vision, the kind of, you can say, it's the nuances within my architecture that I, as an architect, have to stay true to. If, for example, I am saying I will use a workflow engine, okay, in my architecture to run my business process flows, in my immediate architecture, I might not be using, maybe I'm doing it on SQL. I'm not using a dedicated workflow engine. But that does not mean future I will say, no, I don't even need a workflow. Because then I am not even true to my architectural intent. My architectural intent cannot change that much. Because then it would be complete chaos every sprint if I change my architecture. Today I have a database server. Tomorrow I am saying, no, I will not use a database server. I will use a cache, Redis cache. This cannot go on. But yes, in my architectural intent, I might have a Redis cache and a SQL server as a backend. As part of my immediate architecture, maybe I don't have the bandwidth, the effort, or the funding, or the budget to have a cache. So I might remove the cache, but it's in my architectural intent. So this journey from immediate architecture to architecture intent is what is called the agile architect's journey over the roadmap. That is very, very important to kind of understand and account for. Okay, so this is very important from immediate architecture to the architecture intent over the architectural roadmap. This is an agile architect. And an agile architect does not draft model, does not draft structure. Rather, they clarify the intent and the vision. This is the architectural intent I'm talking about, and they offer a direction. They build a roadmap, then they trust their teams to follow that roadmap. And then over time, they invite experimentation. They are not only designing a solution end to end, they are kind of, how to say, like they're putting on the hat of, just like you as a developer are changing with the requirements, as an architect also, if I'm an agile architect, I will also change with my requirements, but I will have a good intent to reach my architectural vision. As part of this, this is the part I was talking about, architecture design records. What is an architecture design record? Say, for example, I have two options. I can go with a SQL database, or I can go, for example, with a NoSQL database. Okay. So, for example, based on the customer requirements, based on the customer inputs, maybe I have chosen a SQL database as a result of all of the requirements, all of my decision making. Initially, I might not have known which to choose, but over time, based on the requirements, I now know that NoSQL is a much better option than the NoSQL, because the customer needs consistency and integrity in the data over anything. And they are much more comfortable with a relational kind of database because of the foreign constraint, because it has a constraint system with primary key, foreign key. So I need to record that as an architectural design record in my solution architecture deliverables, because this is the record that the next architect will kind of know. And when that architect will read maybe I have left the company, but my architecture design record is still in the system. So when I will read that architecture design record, okay, or my colleague who has taken up that, or my follower who is doing that, then he will know that, okay, these are some of the steps that you have to do. And these are the steps that led my previous architect to kind of conclude on NoSQL database or a SQL database. So this is the architecture design record. This is one of the deliverables that an architect should produce. Along with that, obviously, solution architecture diagram, different kind of security perspectives or different kind of views, and all of that is also very, very important. So again, I will maybe take a 1 or 2 minute stop here, and I will try to adjust this slide also. I think there is some problem. But yeah,
Yeah.
any question? Uh,
Yeah, I think there is a lot of question. I think
okay.
yes, let's go in this mode so that we just come back here. I think Ria Raj is asking how is cloud computing impacting your work every day. So I think this is an amazing question.
Exactly. No, see, as a cloud architect, that is what I do, right? I mean, I started my journey as a Android developer in Samsung in 2012. Okay, then I was a home screen developer. I used to work in Java and Android. From there, I kind of came back. That is in Samsung Delhi, basically in Noida. Then after working there for 3 years, I came back to Kolkata because it's my hometown, and there I joined PricewaterhouseCoopers. There I had joined a team as a Microsoft practice. So I used to write C sharp code. I used to write SQL Server, stored procedures, SSIS, DTSX packages. I was a complete, how to say, a full stack kind of a guy, but again, complete developer. Then one of our applications got migrated to Amazon Web Services, and I was the technical lead for that migration. That is when I got introduced to cloud. And after that, every single day I'm learning new things in the cloud because the cloud itself is very complicated. Getting started with cloud is very easy, right? That is why people start with cloud very easily. You just read 3 or 4 YouTube videos and you can create a AWS EC2 instance or whatever. But over time when you start handling the challenges, the computational challenge, the lack of capacity, maybe some of the microservice architectures, the different patterns, so that is where things get interesting, and that is where the big money is, very frankly. Nobody will give you a lot of money to create a virtual machine and a virtual network and some NSG rules in the portal. Nobody cares, very frankly. It is good for projects and learning, but at the end of the day, you need to add strategic value. You need to add architectural kind of advice and architectural insights, and that is why you need that architectural mindset. So over my journey of 10 years, I have kind of changed that mindset from kind of a developer to an engineer or a developer, and then to kind of an architect. And over time I want to become kind of like a CTO or an enterprise architect, a different kind of another vision. So this journey is what is kind of keeping me up every day, and one of the most important things to be very proactive and be successful in that journey would be to follow other better architects. What are they doing? What books are they reading? Let me read that book also, because that is the only way. Because architecture is not something you can just learn, very frankly, right? It's not very easy to learn. You can learn a programming language like Python, but you cannot learn architecture very easily. That is why you have to kind of follow, see what they're saying, get into those projects, think of a little bit more than what you are doing. Say for example, just as an example, say somebody has given you the work to write a script, a very simple script to back up all VMs in your system. So your subscription in Azure, you have say 20 subscriptions. Across those 20 subscriptions, you have 100 virtual machines, and all of those virtual machines are backed up using say Azure backup service. You need to do a reporting, very simple reporting of which backup succeeded, which failed. Very simple report you can write in PowerShell, Python, whatever, using SDK. But you should not stop there. You should think about, okay, what happens if my script fails? Where does it log? What happens if my script fails and I want to retry it? How do I do the retry? What happens if an API call to the Azure infrastructure fails? How do I handle it gracefully? So this is where you are kind of putting on from your developer hat and architecture hat. As a developer, your job is just to write the code and it's good. But as an architect or as a senior developer, on the way to an architect, you are thinking about, okay, where will my compute run? Where will this application, where will this code run? Will it run in a Kubernetes service or a cluster? Will it run in an Azure web app? Will it run in a normal VM? Where will it run? Where will it log? How will it log? How will I ensure that I get access to the log as a developer? How do I timestamp the log? All of those kind of questions, if you just go a little bit more into the depth, then you kind of get some of this complications answered. Hope this answers the question at some level. And anything else, Vishwas,
Yeah.
or? Yeah.
I think there are a lot, but I think what is the tool that you use for architecture diagram? I think that's a
Yeah,
funny
yeah,
question.
yeah. So I in Accenture I used initially Visio, okay, because we had a license. So Visio was our go-to tool, and we are now very popular again. Something I had initially used in PwC, I have not used that much here. Is Draw.io. That's also a very popular tool. Then you have Brainboard. Brainboard also something I use personally. You can very easily move from Terraform to infrastructure, from infrastructure as code to actual architecture diagram, from architecture diagram to infrastructure as code. So now, very frankly, there are many tools. There are very good tools where you can just drag and drop, and you can create an architecture, and they will even create the infrastructure as code or the Terraform code for you. So I personally don't think that it's a problem to create the architecture diagram. It's a more problem to understand the architecture diagram, understand what are the different views of that architect. When I take interviews of an architect, I don't tell them that, okay, create a very complex asynchronous state-based, or for example step function-based architecture. I start with a very simple three-tier architecture and then try to understand, okay, what happens if your database fails? How do you add redundancy at your database level? Okay, what happens if your application fails? How do you add redundancy at application? Okay, what happens if, for example, it takes latency is high? What can you do to, so how do you do retry? How do you do, for example, resiliency? How do you increase the availability? How do you deploy across availability? Very simple questions, but that can. So more important from my perspective is understanding the core components which can help you create the actual architecture. Perfect. Anything
Sure.
else? Vishnu?
I think
Or
I think there is a lot of question. I think you just have to complete the session and we'll just go on with every question, sir.
okay, 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 perfect. I will try to keep it
Sure.
simple. So now, when I initially what we discussed what is architecture, who are architects, why do we need architects, all of those components, right? Then now what we did is something around agile architecture. Good. But what is enterprise architecture? To do enterprise architecture, you first need to understand how do we define an enterprise. An enterprise, in a sense, is a big company, as simple as that. Multiple departments, multiple locations, spread geographically across the world, hundreds of teams and departments. You might only know your direct colleagues. You might have interacted only with a handful of people. Everyone has very clear responsibility and hierarchy. This is kind of like an enterprise. Some examples could be Ford, General Electric, Walmart, United Health Group. So these are some of the well-known enterprises. And what is we mean by at scale? An enterprise works at scale. Scale means at a rapid pace, but also across a large number of entities. High pace, high velocity. Basically, what it means is that any initiative that you take in an enterprise affects hundreds and thousands of developers. For example, if say in an enterprise like say Amazon, say they decide that no, I will start using a Lenovo laptop and not a HP laptop. Just think about the impact of that decision. That will impact every single of their hundreds and thousands of developers. So even a small decision like changing the laptop, or even a smaller decision than that, for example, that say they say that no, I will not keep 3 months of email, I will only keep 1 month of email. Even that small kind of a decision will impact hundreds and thousands of employees across Amazon. So this is what an enterprise, every single thing you will do at a very large scale. So, how do enterprise architecture teams can be structured? So, this is a well-known architecture model that many teams follow today. This is called collaborative enterprise architecture team. What happens there? There is a central enterprise architecture team, which has chief architect and which has enterprise architects. And then you have the delivery teams. Delivery teams might be your project teams. Project team A, project team B, project team C. Each of these architects, you are basically loaning an architect from here to here. So they are embedded in your delivery team as their architecture, but they are part of the enterprise architecture group. This is called collaborative enterprise architecture. Most of the companies today you will find are this is the model that they follow, the standard enterprise architecture model. Another standard architecture model is called enterprise architecture as a service. What does that mean? You as a requester, you need an enterprise architect. You send a request, somebody will be assigned to you for that moment. You will give a work. They will, once the work is finished, they will kind of go back to the pool. Okay, so they are not long term invested in your project. They are not part of your project as such. They are kind of providing their architectural service. So say you have a project where you need an architecture diagram. Okay, a new integration is happening. You don't have an architect. You go to this group, you raise a new request, and an enterprise architect comes, works with you, tries to understand your problem, creates the architecture diagram, provides creates all of the architecture deliverables, then goes back. So this is traditionally how architecture teams are working. This is still less. This is more you will see. Okay, but this is not a very good way. If you see the new kind of architecture teams or the new kind of structure that we want something where we have this stream aligned team. What is the stream aligned team? The stream aligned team is your business team. They are doing a business. Say, for example, you are working in PayPal. You have to create a credit card transaction portal. So this stream-aligned team is focused on creating that credit card portal. But they need some help, say for example, with the processing, how to handle hundreds and millions of rows and records. That is where this enabling team will help them. They will help this stream aligned team. They are not part of the stream aligned team, but they're helping the stream aligned team, collaborating with them and helping them achieve their objectives. This enabling team might have actual subject matter experts who have solved this kind of high scale problem of hundreds and thousands of records earlier. So this enabling team is kind of collaborating with this stream aligned team. But then what is the platform team and the complicated service system team? The platform team is, for example, where I belong in EY, we offer the undifferentiated services like, say, compute, storage, network, all of these services we are providing so that a stream-aligned team does not have to create this. So when a stream-aligned team starts working, they should not think about where should I get my Visual Studio, where should I install my Visual Studio, where should I run my application, where will I get my compute, how will I get my storage. All of that will be taken care of by this platform team. They are organized to support and provide service to the stream aligned team. And what is the complicated service system team? This is a very, how to say, like a very short duration kind of a team which is created for very particular purpose. Say, for example, you have created this solution and now you need to certify it from a PCI DSS kind of a perspective, which is a very well-known security certification that you need for the payment industry. Okay, so this complicated subsystem team might be created just for that problem, to handle that complicated PCI kind of a system. Once this is done, then this platform team will be kind of taking care of the stream aligned team will then maybe even dissolve the complicated subsystem team. So the stream aligned team is your business team. The business team is being held by the enabling team. The complicated subsystem team is a small team that will be created for a very complicated use case, and the platform team is offering undifferentiated services. So now with this in mind, how can we structure our architecture teams, right? Because we are focused on architecture, we are not focused on the entire enterprise. This is a good way. For example, this is the pattern which is called architecture modernization enabling team. What does that mean? Say, for example, you need to modernize a monolithic application. Monolithic application is what? An application which is everything bundled together. I want to split it into microservices. So I have this stream aligned team 1, team 2, and team N. All of them are collaborating, right? But they need an architecture team to enable them. If you remember, there we needed an enabling team. So this enabling team here is this architecture modernization enabling team. They have all the architects and the good people who have good knowledge of the domain and good knowledge of the actual modernization practices, who will help the stream aligned teams to modernize that monolith. Now the question is, does this architecture modernization team need to be for the entire life of my project? No. Once your stream aligned teams have taken the knowledge transfer, have understood what they need to do, this architecture modernization team will cease to exist. So the overall idea here, see here, if you go, what was the problem with this? The problem with the delivery team was always dependent on this architecture team. Because what was happening, this architecture guy has gone from here to here. The moment he goes back, this delivery team doesn't have anything, right? You are just loaning a resource, so to speak. Same concept here, right? Whereas here, what we are trying to say, we are saying no, this architecture modernization enabling team will enable the stream aligned team to take the decisions on their own. They will not have to rely on anything else. So the AMET team will kind of help the stream aligned teams 1, 2, and N to own the architecture practice of their respective domains end to end. So that is why if you see over time, if the blue line is the architecture modernization enabling team. As you can see, initially there is a lot of investment needed in the team, but over time there is no longer necessary. AMET no longer necessary. Whereas the architectural capability of your team is constantly increasing. So at this point, do you really need another team? No, because all your engineers, your architects within your team are already capable. They have already understood what is it that is needed to do an end-to-end kind of a architectural modernization. So this is also very important, how enterprises structure. You might think that why am I focusing on structure so much? Because this structure in enterprises, you cannot compare it with a startup with 100 or 500 kind of a people. When you compare it with the company like me, which has 3,50,000, even if I take a small decision as an enterprise architect that can impact holistically 3,50,000 people, maybe 70,000 of them are just developers, right? So in that moment you have to have this kind of collaborative approach where each of your teams are kind of skilling up over time. You cannot rely on an external team to come and solve all your problems. You have to have a collaborative approach, a consensual approach, and then kind of do this. Very good. So now I will come to the conclusion very quickly, and then we will take some questions also. Develop an architectural mindset. So this is very important to become an architect. Today, many of you might have been, say, 1 year, 2 year, 3 year, 4 year experience. You might say, no, I'm not getting any architectural work, which makes sense. There are people with 20, 26 years of experience who are now doing architecture. Obviously, it's complicated. I am doing some level of architecture. I have architects over me also. So developing that mindset is very important. And how do you have already taken the first step because you are listening to this webinar? Means you are interested. That is the number one step. If you are interested, you can go to YouTube. Knowledge is already democratized. You can find a way to get more information. Even today, very frankly, I will tell you, when I work from home, I start the morning around 7:30 or 8 to 9:30. I just see other YouTube videos, not like normal reels or something, actual technology videos. Maybe I'm listening to, for example, Adrian Cockford, or I might be listening to Gregor Hope, or maybe I am reading something from Joel Spolsky, whoever, it doesn't matter. So it helps me develop an architecture mindset. This is where I get all of these ideas about structuring. How should I structure my team? How should I think about architecture, right? Because you get inspired from this. So develop an architecture mindset is very important. Be a socio-technical facilitator. So as an architect, like I said, the main job of an architect is to enhance collaboration, nothing else. If you can help people collaborate among themselves, then you are a very good architect, because in an enterprise nobody is speaking to each other, everybody is working in silo. If you can take the inputs from this team, take the inputs from that team, drive some sort of a consensus so that both of them are working together for the particular vision, which is your architectural vision or your architectural mindset. That is what is important. Once you have the architecture mindset, it's very easy for you to be a socio-technical facilitator. Talk to people. Architects have a lot of talking to do. 80% of my time in office is spent on talking to people, understanding their problems, trying to figure out what is it that we can do better from a platform perspective, what is it that is not working. Say somebody saying somebody saying something else, trying to kind of understand what is the common trait, focusing on that. So facilitation and collaboration is very, very important from an architecture perspective. Be hands-on as much as possible. I still do Udemy courses where I am trying to set up a Kubernetes cluster, connect to it, run some C# is my favorite language because I've worked on it a long time. So maybe setting up a database, writing some very simple tables, maybe creating a to-do application. So be hands-on. Don't be an ivory architect. That is also ivory tower architect or an architect astronaut, as Joel Spolsky love to call them. So be hands-on and record all architecturally sensitive decisions. This is also very important. I have seen many architects don't do this. That is why I'm mentioning it here. Architecture design records is very, very important, as is all of the architectural deliverables. But this is particularly important because you yourself might forget why you had decided. If I ask you, say today after 1 year, that why you decided to go with a virtual machine and not say a web app, you might not even know. So this is why recording architecture sensitive decisions is very important. and be thoughtful in your team structure. How you structure the architecture team of your organization will impact how your organization behaves. Very, very important. This is Conway's law. Okay, this is already proven year in, year out. That you have to be thoughtful. Just don't think, okay, I will take an architect from there, take an architect from there, create my no. Think about think about the team topology topic that I showed. Does it make sense to have an architecture modernization enabling team support those guys in their architecture journey and then take a step back? Maybe yes, maybe no. So think about, be thoughtful, be decisive, and be conscious of the decisions you are taking with regards to your team structure. These are some of the references. I will share the slide deck also so that you have access to it. And again, thank you so much. Again, warm thank you to the Devtron team and to Vishwas for kindly setting this up. And with this, I will end my session. I hope we have some time maybe for questions and answers. And Vishwas, over to you.
Sure. I think let's answer these questions. All right. How is cloud? That's absolutely fine. Two, I think what how do you test and adopt new services? I think that's a great question. That's $1 million question.
Yeah, that's a really good question. And that is what I'm saying. That see, there are two parts to an architecture. One is when you are thinking about it from I want to learn something. Okay, just because you want to learn something, you don't put it in your project, right? So from a project perspective, you only do stuff that you need to do, right? There is nothing, obviously that does not mean that if nothing breaks I will not do. I will obviously try to refactor my architecture up to some level, but again it's not possible. You will never have the budget, right, just to improve your application. So that is where I am saying that if your core architecture is good, is extensible, then you can adopt. So say for example, I follow a few principles. Whenever I get into a project, I always say it has to be API first. I will not kind of say anything. If they are saying no, I will not create API, I will remove myself from that project. It's better. I will always say API first because I know that gives me a lot of flexibility. That gives me the flexibility that tomorrow, if I want to change from say Pega to ServiceNow, or if I want to change from say Lambda to something else, for example, which is a little bit more difficult. But anyways, if I want to change my third-party dependency, it gives me that flexibility. So this is one part. And now adopting new services, obviously you have to follow the structure. You might do a POC, then it will happen on dev, QA, UAT, production. So all of those applications. So also always remember that you are not an engineering lead. So people like us who have come from the development background into an architectural kind of a work, we sometimes think that, okay, let's do it myself. Okay, why is the engineer writing the code like that? I could have written better code. No, don't do that kind of thing. Always know that you are an architect, you are just to guide. You might do a small POC, show them that yes, step functions work like this. These are some of the good benefits, and then you might write, okay, these are the do's, these are the don'ts, these are the architectural principles of step functions, and then you will trust your engineering lead to deliver on that. Okay, so that is very important. I think that answered the question at some extent.
Yeah.
Yeah.
What are the tools that you use for architecture diagram? That's
So,
that's
Draw.io,
also done. Yeah.
Visio, yeah, exactly, yeah.
How is the cloud computing going to change the way we are going to adopt Kubernetes? I think that is the thing.
To be very fair, it has already changed. I mean, Kubernetes has become the de facto compute for most of the applications today. For example, even in many companies that I work with, they have now not even cloud first. They are calling themselves that my thing is container first, right? So but at the same time it's complicated also. Kubernetes is not very simple. So I have a session where I have spoken specifically, it's also on YouTube, on Kubernetes, enterprise wide Kubernetes adoption practices, patterns, and all of that. So I might give you a link and you can see that. But yes, see, Kubernetes you have to learn today. If you say I am an architect, I don't know Kubernetes, it's very difficult for you to get a job. Very frankly, I'm telling you, this is my personal experience. So I had learned Kubernetes I think in 2019. Before that I had no reason. There are still many people you can get away without Kubernetes. If you do managed services like Azure Web App and all of that, you really don't need to know Kubernetes, but it's very good to know because more and more applications want that flexibility, even though they know that flexibility will not add any value, just because of that buzzword, they want to be in Kubernetes space. So we also have to kind of adapt to our customer requirements. So I think we should at least learn Kubernetes. As an architect or as a developer, we should focus on learning Kubernetes. Perfect.
This is something Cool. How is the importance of a cloud to the enterprise architecture?
Yes, I mean, I
And what are the
personally think that,
importance?
yeah. So again, these are broad question, but at a high level, what I can say is that cloud computing helps enterprise architecture in a sense, because now the decisions are much more transparent, but at the same time it makes it a little bit more complicated, because in on-premise the patterns were quite well defined, because people were doing it for 20, 30 years. Everybody knew, okay, this is something you have to do, after that you have to use this enterprise service bus, push all your messages at this end, read from that end. Whereas in cloud, because of this different services, the architect's work has become a little bit more difficult, but at the same time it is more transparent, because you have these tools to play around, you can validate your hypothesis. So I think that cloud computing is obviously a very, very important part, but it has nothing to do with enterprise architecture per se, but it has an overall value, because cloud architecture is very important. It's a very upcoming field already. It's very important. It's not even upcoming today. Everybody is calling themselves a cloud architect. So I think it's good. I mean, you should know about cloud computing. You should know about architecture. You should know about cloud architecture, and kind of try to jot the dots and kind of connect the dots wherever possible.
So I think he has answered most of the question, folks. I think
Perfect.
the all the approaches that is being talked here is always about the perspective about architecting a right solution at that given point of time. I think that's perfect. Thank you so much, sir, for being on the show. Means a lot.
Thank you so much, Vishwas. Have a great day, everybody. And yes, happy to help wherever. If you have any questions, you can just reach out to me over LinkedIn. I'm extremely active there. So I will obviously try to answer as many of those questions as possible. Thank you.
Sure, sir.